Hello, everyone. Thank you for joining today's webinar. We really appreciate your time. I'm Gabe Geller, and I have my colleague Joe Goldberg with me. We're both from the Digital Business Automation Solutions marketing team here at BMC. Joe has decades of experience with the design, development, implementation, sales, and marketing of enterprise solutions to Global 2000 organizations. Today, he's going to talk about how to orchestrate business applications with a DevOps-enabled Jobs-as-Code approach, and we'll include some information on BMC's digital business automation platform, Control-M. A couple of quick housekeeping items before we get started. We've got tons of great DevOps and Jobs-as-Code content available for you in the Attachments tab on your screen, and there you'll find white papers, blogs, analyst reports, and more. And if you're on Twitter, we're at Control-M_BMC, and at Jobs-as-Code. Be sure to tweet us and let us know what you think about today's presentations. If you have any questions, please be sure to submit them online, and we'll cover as many as possible at the end of today's session. At this time, I'll hand it over to you, Joe.
Thanks very much. And again, hello, everyone, and thanks for joining our webinar today. The discussion today is really kind of looking at what has transpired in the world of business application orchestration as CI/CD and DevOps has been embraced by organizations. So I'd kind of like to talk about this as perhaps looking at it from two separate perspectives. And for traditional organizations, orchestrating business applications has typically been the job and the domain of IT operations or scheduling, and they have used a certain category of tools. As application developers have assumed some of that role, the desire has been to sort of streamline and automate the entire software development lifecycle, automate the delivery and deployment of tools. The tool sets and the automation facilities that developers and engineers have been familiar with has become a choice for promoting and automating the entire sort of application lifecycle, including operation in production. And what I'd like to talk about today is the considerations for orchestrating business applications in a production environment, but using the tools that are specifically built for that kind of functionality, as opposed to perhaps using other kinds of automation tools that, although are great for what they were intended for, are not necessarily the ideal choice for operating or instrumenting business applications. So if we kind of take a look at what are the categories of automation that I'm referring to here, if we look at the this stack from the bottom up, first I'm looking at config management tools, infrastructure management tools, tools that implement as infrastructure as code kind of an approach. These could be tools like Puppet or Chef or Salt or Ansible and a whole bunch of others. And their goal and their function is to be able to implement a software-defined approach to managing infrastructure and to managing what previously was physical hardware exclusively, but now being able to manage and configure it in a more automated way with some tooling. The next layer is, I think, the set of tools that focus on application release. So this is build automation, testing automation, deployment tools, application release. And then at the top, we have what is the category of tools that I'm referring to here, which are business application orchestration. These are the tools that automate how applications operate in a business environment, and all of the orchestration that is necessary to manage either dependencies or relationships among the various components of applications as they run, delivering the business services that they're intended to deliver. Now you notice that the arrow on the left-hand side is going from top to bottom, and really the primary reason for that is because no matter how long it takes you to build an application, ultimately the significant majority of an application's life is going to be spent in production. And so the value of how you orchestrate and operate it in a business environment, in your data center, in your cloud environment, whatever the production, customer-facing or business-facing way that applications are exposed, that automation is going to be probably most important in determining how the value of that application is going to be realized and delivered, and whether you're going to be able to operate it efficiently or not. And so if you kind of look at what is that whole nature and the whole body of orchestration that we're referring to, it's been known by a lot of different names. It's been known as workflow orchestration, it's been known as job scheduling, as batch management, and today, as application architectures are changing or evolving, there's a tendency to think or to focus more on either real-time or how applications are going to operate in microservices environment, and the thought is that maybe this kind of orchestration is no longer that important. And so we undertook a survey with Forrester just a short while ago, and we discovered, or I would say we've really kind of substantiated what we thought was always going to be the case, that the vast majority of practitioners believe this kind of orchestration is either maintaining at current levels and frequently even increasing. So as complexity increases, the number of components increases, the diversity of your environment increases, this kind of automation is absolutely going to be critical. But I think the new focus is that you have to be able to build and test and deliver this kind of orchestration using the same kind of techniques and methods that you use for delivering your application or business logic. And we talk about this as a jobs-as-code approach. And we found that this is the kind of an approach that, as you can see, about 80% of practitioners are either already using or thinking of using and working towards implementing. So what are the characteristics of this kind of an orchestration platform or this kind of facility that is required in an enterprise environment? Well, so here are sort of the categories that we believe are critical to making sure that you are able to achieve this kind of business orchestration in a consistent way. So first of all, you have to be able to get sort of an end-to-end view of the entire business service. So one of the things I said earlier is that we are seeing complexity actually increase. If you're taking a multi-cloud approach, you're now running application components perhaps on a variety of different cloud providers. Some of them could be private. You may have an internal public cloud. You may have a great number of components as a result of maybe switching to a microservices kind of an architecture, where before the application was relatively monolithic. Now you have really quite a number of pieces in flight and operating all over the place. And so you really need to be kind of able to abstract all that complexity and to elevate your view to a point where you can say, what is happening with my business service? Is it running on time or not? Is it successful? Is it running the way it should? Being able to gather metrics, do things like service level management, all of those kind of things really demand this kind of end-to-end view, and we think that that's absolutely critical in this kind of facility. Of course, if you're running at web scale or an enterprise scale, it has to be enterprise grade, and it has to have auditing and security, and it has to be robust, and it has to be stable. So all those kinds of expected requirements have to be in place. One of the things that I think is really important is the diversity of users that exist in large environments. So frequently tools that come from the development side, they may have been catering to a technical audience, really great for that kind of an audience, but when you get into an enterprise or out into the wild, so to speak, you may have non-technical users, business users that are somewhat familiar with technology, but not very much so. The expectation for user interfaces and the way that you interact with technology is different and diverse. And that has to be one of the things that you really need to consider. Of course, today everybody's talking about cloud and containerization as kind of the infrastructure of choice. And whatever platform you choose must be ready and enabled for those kind of environments. But I think it's also really critical that whatever choice you make is extensible or you can, pluggable to a point where today we may be talking about cloud and containers, but tomorrow there may be something else that goes even beyond it. And certainly that has been the progression we've seen in the IT marketplace. And so you have to have a solution that is capable of evolving as your technology needs evolve. And then finally, it's this notion of completely integrating into an automated software development lifecycle. And this is the jobs as code part that I was referring to earlier. In order to be able to do that, there's a variety of requirements that an application has to meet or a piece of software has to meet. You have to be able to code things in a text-like format so you can store it in version control. You have to have the right kind of APIs that support all of the functions and the different phases of an SDLC. And we're going to be talking about that in a few moments as we get into a bit of a demo. And so this becomes a really critical set of components you really need to look at. And I think this is what drives sort of domain specificity for a solution that is intended specifically to orchestrate or to instrument business applications, as opposed to the kind of tooling that may be more appropriate for other kinds of domains. So a couple of use cases from customers that have, in our case, the platform that we're talking about. Of course, this is, if you weren't aware, this webinar is sponsored by BMC Software, and our solution is called Control-M. And so a couple of our customers that have been very successful with this platform, and they have taken or embraced this kind of approach, and not only embraced it, but actually worked with us to help us drive towards that kind of an approach. So PayPal is a fairly well-known, hopefully a household name familiar to most of you, if not all. They have gone through a transition where the entire organization and their development teams have adopted and embraced a DevOps approach. And just a few short years ago, a joke around PayPal was that the job of developers was not really to develop code, but to open incidents, because every action required a manual service request to be opened, wait for the approval process until the function that was required was completed. Of course, this caused massive delays. Things that should have taken just a few minutes or perhaps hours were taking days or weeks or even months. This was true also for building orchestration for applications. So as applications were being built, then a request would have to be submitted to some centralized organization to build those workflows and test them and then eventually implement them into a production environment. Switching to a jobs as code kind of an approach meant that they were able to have developers build and test these application workflows as part of their development process. In fact, they undertook a massive project to build a sort of a developer user interface that automated quite a number of functions that previously had to be done manually, one of which was the process of building and testing workflow automation for business applications. And they were able to achieve massive improvement and acceleration that allowed them to build applications and get them into production orders of magnitude less time than previously, and at higher quality, of course, because they were able to not only build the instrumentation at the same time as the application was being built, but that instrumentation traveled with the application through the entire delivery pipeline, including all of the testing that had to be done. Another customer that was able to achieve great success was a company called Amadeus. They are a bit more of a backroom kind of company. Some of you may be familiar with them, but they provide IT services to the travel industry. And in fact, they provide about 70% of those services from an industry perspective. They are the processing behind many airlines, many travel websites, and they touch about 95% of all commercial airline bookings. They still have one of the most sophisticated set of data centers in the world in terms of volume and processing capability. But of course, as the internet drove and continues to drive volume significantly higher, also with the need to be able to deploy their applications in customer environments, they needed a platform that would support a modern infrastructure. They switched to and implemented a private cloud, along with an approach whereby all of the workflows that were created and were running in their traditional data center could be ported into this new environment seamlessly, and in fact could even travel back and forth. So as they were transitioning, and they expect to be transitioning for a number of years, they are able to run their applications and all of their workloads in whatever environment is best suited for this application at the particular moment in time. Okay, so let's take a little bit of a look at how this would manifest itself within a development process. So let's say you are architecting, designing, building a new application. In this particular example, we're looking at a vehicle predictive maintenance application. So we've got a bunch of trucks on the top all the way at the left. Those trucks are instrumented with a bunch of sensors, and that sensor data is flowing into our environment. It may be streaming via a variety of different tools. It doesn't really matter, but at some point it lands somewhere where we will apply some kind of regression model to determine if the sensor information is going to be indicating some kind of potential failure. What our goal is, of course, is to minimize the downtime or the amount of time a truck or a vehicle spends waiting for service, and to repair any potential problems as soon as possible, because at that point the vehicle is still mobile. It can take itself to a service center instead of having to get towed. So the entire process is going to be much faster, cheaper, more efficient, and will keep the truck on the road. Now, in addition to this kind of real-time streaming portion of our application, there's a whole bunch of other stuff that may be going on that is less real-time. So, for example, we may still have traditional systems that keep our customer data, warranty data, parts data, service center data, and a bunch of other things that are necessary, so that once we get a potential failure, we need to enrich that data to identify the truck and the part and where it happens to be in the world and whether there's a service center available. If the part is not available, we may need to order it, and of course that requires us to wait. If the service center doesn't have a bay or a technician available, that may require additional wait time. There may be notifications that we need to respond to. And so this kind of flow is a good example of what modern applications look like, which are a combination of streaming, real-time processing, along with some kind of deferred or more traditional kind of processing based on either extracts or traditional applications. So let's take a look at how we would build such an application. Okay, so at this point, I am looking at an Eclipse IDE. So this is my development tool, and I am building my application, which consists of the flow that you saw earlier. So there's a component to capture the data. There's a component to do the movement of it, which will be, let's say, a file transfer. There are some extracts. There's, of course, the logic for doing the regression and the modeling of what looks like a failure, how to detect that. And you can see the different tabs that are part of my application, but there's also the one we're looking at now. The current one is my orchestration. This is the one that's going to determine when I get a piece of data that looks like a potential failure, what are the things that I'm going to do, how am I going to take the data that comes into my organization and process it. And the flow that I have here is this is all running on AWS, by the way, but that's kind of irrelevant. I'm going to create a Hadoop cluster. In AWS terminology, this is EMR. So EMR is AWS's Hadoop facility, stands for Elastic MapReduce. And this is the job that will create it. And then after I create that, I do some configuration and setup. Because I've just created this cluster on the fly, I'm going to then push some of my application components to that cluster. In this case, some of the jar files that make up the analytics. The data that may have come in from my sensors, I'm going to apply my model to that data. I will get some results. I'll take those results. I'll do some notification. Again, here I'm using SNS to send text to drivers, and then eventually sort of deconstruct and delete the entire environment. Now that's the instrumentation that I want to perform, and what you can see here is a way to define or describe that instrumentation using a JSON notation. There are three major portions to this. So at the top I have a bunch of defaults. This is some specifications or attributes that will apply to all of the jobs or the tasks in this entire flow, because they're kind of standard either error actions or notifications. Then I have the individual tasks themselves. So again, creating a cluster, doing some setup, doing some file transfers, running the actual predictive model, getting some output, deconstructing it, and cleaning up. And my last sort of set of statements here define the flow. And so this is the relationship or the sequence that I perform the first task. If that's successful, then I perform the second, and so forth. If this was a more complex flow with multiple branches, I might have multiple flow statements that define each one of those branches. So I'm a developer. I may be primarily, in this case, either Scala or, let's say, I may be familiar with Spark, but also, I don't know, some other languages. I'm probably less familiar with this kind of notation. So certainly this is JSON, so I know the structure generally, but I may not be fully familiar with the actual DSL and all the specifics. And so the first thing that I need as a developer is a way to verify that what I'm doing is correct. And so there is, in addition to this notation to access the workflow and coordination capabilities, there is also a set of APIs that expose a variety of different functions, one of which is the ability to validate. So I will, and we call this the build service, I will invoke this build service and determine, in this case, that everything is successful. If I were to, let's say, change something, let's say I made a mistake here, just to see what that looks like, save it, do the validation again. I should get an error telling me that command is misspelled or is unknown. Let me fix that, save it, and just verify that we are working with valid syntax. Okay. Now, I happen to have a test environment available to me, and that too is running on AWS, of course. I have a test environment that I have provisioned, possibly part of my request to, or my mandate to start and build this application. I got a test environment, and there's a variety of different ways that that can happen. Now, validation is great, so I know I have the right syntax, but this is code, and the intent of this code is to make sure that my application runs successfully. So for me as a developer to be certain that I am at a good point where I can commit this and pass this downstream into my automated build process, I want to be able to run this. And so we have the ability here to also do a test. So let's submit this work, and we can test it. And what I'm doing here is I am sending this request to my coordinator, in this case Control-M, so that it will actually run the jobs and see if they run correctly or not. Depending on how I've set up my data and my other environments, we get a full end-to-end execution. Now, when I submit a test, what I get back is this run ID. Now, we'll get back to that momentarily and look at that run ID again, but there's a variety of ways I can now interact with this environment, including looking at a web interface that lets me look at my flow and interact with it. So we'll start that up. See how that looks. Okay, so here's our flow. It happens to be in a status called wait user. That means I didn't want it to run prematurely, so I want to have the opportunity to say, okay, it's okay for you to run. So if I confirm it, it will then begin execution. But I also have a full set of APIs that could do the same thing. And so in addition to using a web interface, I also have a CLI and a set of RESTful web services. The CLI is a Node.js module that just implements those web services, and I have the option of looking at the status of my jobs either in this kind of tabular fashion using web services or a CLI, or using the web interface that I showed you earlier. So if we look at the jobs, so the same sequence of jobs, the first one is a folder, which is an object that collects all of the jobs within it. And if we look at the next one, we can see that it's status wait user. Now, I can right-click in the web interface and confirm that job and let it run, but then I can accomplish the same thing here. So let's do it this way. Oop, I misspelled. Pardon me. Okay, so I'm going to confirm the job, which should change the status of this job from pink or whatever that color is. Now that it's confirmed, if I refresh, you can see that it's now yellow and running. Now, the reason I wanted to get into this console is now talk a little bit about the services that are provided. Now, we're using the CLI, which again is kind of just a pretty interface over web services or RESTful web services. If you're using a tool that speaks RESTful, whether you're using PowerShell or curl or any other tool that can invoke web services or RESTful services directly, you can do that, or you can use the CLI. But the intent of this CLI and the intent of all of these services, and if you think back to a statement I made previously, is to look at and examine the entire CI/CD delivery pipeline and look at the things that are necessary to be able to fit such a solution into this kind of a pipeline at all phases. And so previously when I did the validation of syntax, that was using the build service. When I wanted to run, or what I'm doing now, is using the run service. This run service lets me run jobs and interact with them. I can fetch the output, the logs. I can, as you can see, confirm them, rerun them, kill them, perform operational actions. When I'm ready, eventually I can deploy. And we'll see momentarily when and where I might want to use that. But I also have config and provision functions. Now, these functions relate to configuring and provisioning this solution, this automation solution, as kind of middleware in my environment. So if you think about an automated pipeline, I've written my code, I may have done a build, I now want to test this. In order to test it, I'm going to instantiate an environment. That environment will consist of course, the OSs, databases, web servers, whatever other components, and my orchestration middleware. And so I want to be able to provision and configure that in a fully automated fashion, and these capabilities allow me to do that. So let's take a look at one other thing, and then perhaps we'll be in a position to take some questions. So let's assume I've built the code, and well, let me just return to the IDE momentarily. I'm actually looking at a Git repo here. And at some point, if I would have iterated through the validation and execution of these jobs to a point where I'm satisfied with them, I would then commit the entire application, including my instrumentation or my orchestration, to my Git repo. And when I did that, or when I do that, I would then launch, either in an automated fashion or in some kind of a polling fashion, a build. In my case, I'd be using Jenkins here. And I have a very simple build here. So if we take a look at what that build consists of, okay, there's a bunch of stuff, well, something I guess I need to fix. There's a bunch of stuff related to the application itself, so I might compile and assemble my business logic, and then I'll do the same thing for my instrumentation. And it is here that I will use these operations that I just showed you via the command line. And again, whether I use command line or directly invoking RESTful web services is just simply a matter of choice. So I commit my code to a version control system. We happen to be using Git. That's going to drive my build. The build is going to redrive the collection of all the bits and pieces, making sure we have everything in place, running validation, running perhaps even some tests. And if I have a testing framework, as I do here, I would be able to invoke whatever test cases I've already designed. And so let's see if we can very quickly look at. This happens to be a Jenkins machine, but it also has robot on it. And we can take a look at what these tests look like. Oops. I think I'm typing a little too quickly. Okay. So here is my set of test cases that I have defined to robot that will also be invoked by my build process. And so the intent of this approach is to be able to deal with jobs or orchestration for my application in exactly the same way that I deal with either infrastructure or my actual business logic, all of it being treated as code, committed to a version control system, traveling through an automated pipeline, including ever-hardening and increasingly complex testing so that I can then deploy it into a production environment, either in a fully automated way or in whatever best suits my organization, but with confidence that the instrumentation that I've created is valid and will operate correctly in my environment. So at this point, if I could just return to our slides, and I think as Gabe had mentioned in the opening, there's a lot more information available about this kind of approach on our website called jobs-as-code.io. I would encourage you to visit it and learn a lot more about instrumenting and operating business applications using this kind of an approach. And at this point, Gabe, if there are any questions, maybe we could take some.
Great. Thanks, Joe. Thank you for the presentation and demo. As Joe mentioned, we've got a couple of minutes to take a few questions. See a couple coming in already, so just as a reminder, if you'd like to submit a question, please do so through the online portal. Joe, the first question I see is, are there any technical requirements or restrictions for using Control-M?
Okay, well, great. Thanks for that question. I didn't focus on this, but in everything that we have done, obviously you need Control-M itself, but that's available in a variety of different ways. But in terms of how you access it, everything that we have done in enabling the kind of access that I've been describing is making choices that are either real or de facto industry standards. So when it comes to application integration, really the standard nowadays is RESTful web services. The language for communicating via RESTful web services or a RESTful enabled application is JSON. And so the intent is to use things that are already familiar to developers, that are part of a developer and an engineering ecosystem, to make the sort of the ability to absorb and to take advantage of these kinds of facilities as simple and straightforward as possible. So I guess the answer would be, generally, there are no specific requirements. Whatever your organization happens to use in terms of tooling, because we are using industry standards, we adapt and can be embedded in all of those.
Great. Got time for about 2 more questions. The next one is, in my organization, we still have gates to production that require reviews and approvals. How do you deal with that?
Okay, so one of the things that I didn't spend much time on, but of course Control M and access to it is now exposed as just a RESTful endpoint. And the environment that I was working with was my own personal private environment that I launched on AWS. And there's even a marketplace offering, so there's an AMI available. It takes like 3 minutes to get a Control M environment up and running. And so you can automate this entire process, of course, and you can give individuals access to it as necessary, so that if you look at how your development pipeline progresses, if it's automated up to a pre-prod or a UAT environment, then you can certainly, as the techniques that I showed, use it to automate and to deploy to that environment. And then moving from that environment, there's still a bunch of traditional capabilities that are available within our core offering. We have something called Workload Change Manager, which provides support for promotion rules so that you can have a manual or an automated gate that approves and then moves that forward. And there's, of course, a fully manual method which some companies are still using and are transitioning from. So you have a great deal of flexibility.
Perfect. Thanks, Joe. And one final question. So how can I get started quickly? Do we have a community edition, or is there something similar?
Okay, great. So you can, there's a virtual appliance, which is in effect a community edition of Control M, pre-configured and pre-built, called Control M Workbench. And if you go to Control M, all one word, no dashes or anything, controlm.github.io, and you can get this from jobs-as-Code.io as well. You can find your way there. You can download this workbench, and you can get up and running.
Fantastic. All right, thanks, Joe. Well, that brings us to the end of our time today. Again, thank you to everyone for joining us, and thank you for your excellent questions. If we didn't have a chance to answer your question, we will follow up with you after the webinar. As Joe mentioned, if you want to learn more about what we're doing, be sure to visit our newly launched jobs-as-Code.io site. It's packed with information on jobs as code and DevOps and how companies are leveraging them to build sustainable advantages. Once again, this is Gabe Geller and Joe Goldberg with BMC. Thank you for your time and have a wonderful day.